Good afternoon, everyone. Welcome to I Square Maths Academy, where numbers and variables meet mastery. Today, I want us to look at inverse hyperbolic functions, inverse trigonometric functions. Now, functions of inverse hyperbolic functions of inverse trigonometric functions. In our last class, we actually derived the standard derivatives of sine inverse of x to be equal to this. Yes, that when you have sine inverse of x, the y all over the x is 1 all over the square root of 1 minus x squared. If y is equal to cos inverse of x, the y all over the x is minus 1 all over the square root of 1 minus x squared, down to the sine h inverse of x, which is 1 all over the square root of 1 plus x squared. Now, today we are going to be looking at, if you observe very closely, you discover that here, what you have here is just the function. This is the standard function. Like, for example, when you have sine x, this is the standard function of x. So when you differentiate this, it gives you cos x. But when you have another function taking the position of those x, it becomes a function of function. Example, if y is equal to sine 8x. Now you can see here that 8x has taken the position of x. So it means this is a function of this trigonometric function, just like having a bag inside another bag. Now, in this case, today we are going to be differentiating all these functions. Now, number one, here we are given the following functions, and we are asked to get the value of the y all over the x. So we are going to be differentiating this using those standard derivatives. Now, solution. Now, let's look at question 1. Here we have y is equal to the sine inverse of tan x. And here we're asked to find or solve for the y all over the x. Yes, solve for the y all over the x. Now, we all know from our last class that if y is equal to the sine inverse of x, that the y all over the x, is 1 all over the square root of 1 minus x squared. This is the standard derivative when you have sine inverse of x. The standard derivative of the sine inverse of x. But in this case, we have a function here. Yes, replacing the position of x. Here we have y is equal to sine inverse of tan x. Yes. So in this case, what we are going to do is to assign a variable to this tan x. So here I will say let u be equal to tan x. Yes. So if u is equal to tan x, yes, and we know that the u, or before the u, here we have y will be equal to, we have sine inverse of u. Now, I take it again. Here we have sine inverse of x, y is equal to sine inverse of x of tan x. So now, because this tan x is actually taking the position of this x, now we are assigning u, we are tying this value to u. So we say let u be equal to tan x. So if u is equal to tan x, it means y will be equal to the sine inverse of u. Yes. So now let's look at the u all over the x. Yes, the u all over the x. When you differentiate tan x, you have sec square x. Yes, that's the value of the u all over the x. Now let's look at the y all over the u. Now, the y all over the u, when you differentiate the sine inverse of u, remember we said when you differentiate the sine inverse of x, it gives 1 all over the square root of 1 minus x squared. So it means when you differentiate the sine inverse of u, it will give 1 all over the square root of 1 minus u squared. Yes, that's the y all over the u. And remember from chain rule, recall from the chain rule, yes, that the y all over the x, the y dx is the y all over the u times du all over dx. So it means in this case, the y all over dx will be equal to the y all over du is 1 all over the square root of 1 minus u squared times du all over dx. Du all over dx is sec squared x. So it therefore means that the y all over dx will be equal to 1 times sec squared x is sec squared x all over, because this sec squared x is the same as sec squared x over 1. When you multiply 1 times sec squared x, it gives sec squared x. The square root of 1 minus u squared times 1 will give the square root of 1 minus u squared. Now, but remember, the value of our u is tan x. So it means this will be the square root of 1 minus tan x all squared. Yes, because if u is equal to tan x, u squared will be tan x all squared. So it means the value of the y all over dx. The y all over dx will be equal to, we have sec squared x all over the square root of 1 minus, here we have tan squared x. That is the value of the y all over the x. So the y all over the x is sec squared x all over 1 minus all over the square root of 1 minus tan squared x. Now let's look at question B. Now question B, we have y is equal to cos inverse of e raised to the power of 5x. And here we're asked to solve for the y all over the x. Okay, so in this case, you tell them let u be equal to e power 5x, because the standard function is the cos inverse of x. Yes, that's the standard function. Now you can see that e raised to the power of 5x has actually taken the position of x. So it means now it's a function of function. So here we have u to be equal to this. And if u is equal to e power of 5x, it means our y will be the cos inverse of u. Yes, it will be the cos inverse of u. So now the y all over du. Now let's do it. Now if y is equal to the cos inverse of x, yes, look at it here. If y is equal to the cos inverse of x, the y all over the x is minus 1 all over the square root of 1 minus x squared. So it means if y is equal to the cos inverse of u, the y du will be minus 1 all over the square root of 1 minus u squared. Yes, of 1 minus u squared. So now if the y all over d is equal to this, it means the u all over the x, when you differentiate e raised to the power of 5x. Now this is also a function of function here, because what you have there is 5x. Remember, if y is equal to e raised to the power of x, the y all over the x will still give us e raised to the power of x. Now in this case, 5x is actually taking the position of this x. So it means the u all over the x, now will be e raised to the power of 5x. Then you multiply it by the derivative of this function, which is 5. So that will be equal to 5 e raised to the power of 5x. That is the u all over the x. Now let's see the value. Let's see the value of the y all over the x. Now from chain rule, we said the y all over the x is equal to the y all over the u times the u all over the x. So that will give us the y all over the u is minus 1 all over the square root of 1 minus u squared. Then we have times the u dx. The u all over dx is 5 e raised to the power of 5x. So here we have 5 e raised to the power of 5x. So that will give us minus 5 e raised to the power of 5x all over the square root of 1 minus u squared. And remember, we said let u be equal to e raised to the power of 5x. So here we have e raised to the power of 5x all squared. Yes, all squared. So it means the y all over the x will be equal to minus 5 e raised to the power of 5x divide by the square root of 1 minus, here we have e power 5x times another e power 5x. And we all know from indices that when you're multiplying functions with equal bases, you are adding the powers. Yes, so here this will be e power 5x plus 5x. In that case, this will give us e raised to the power of 10x. So that is the u all over the x. Now we're going to look at the next function. Yes, the next one is tan inverse of tan 3x squared. 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 That's question number C. So here we have y is equal to the tan inverse of tan 3x squared. So here we have to solve for the y all over the x. So here you tell them, let u be equal to tan 3x squared, because this is actually taking the position of x. So now in this case, our y will be equal to tan inverse of u. Yes, now let's look at tan inverse now. Yes, we said tan inverse, when you differentiate tan inverse of x, it gives 1 all over x squared plus 1. So it means when we differentiate the u all over the y all over the u, it will give 1 all over, please we're looking at this, 1 all over u squared, then we have plus 1. 1 all over u squared plus 1. That's the value of the y all over the u. Now let's look at the u all over the x. Now for the u all over the x, when you differentiate this, now remember this is also a function of function. Yes, so when you differentiate this, you have sec square 3x squared, then you times it by the derivative of this function. When you differentiate 3x squared, 2 times 3 is 6, then you minus 1, that will be 6x. So here we have 6x. So it means the whole of this now will give us 6x. Then we have sec squared 3x squared. That's the all over the x. So now it means the y all over the x. The y all over the x is the y all over the u times the u all over the x. This is the chain rule. It means here, the y all over the u, look at it here, is 1 all over u squared plus 1. Then you multiply it by the u all over the x. Now the u all over the x is 6x sec squared 3x squared. And remember, this is the same thing as saying all over 1. Yes, it's the same thing as saying all over 1. So it means in this case, what you have now will be the y all over the x now will be equal to, now the whole of this times this, it will give us 6x sec squared 3x squared all over the value of u squared plus 1. I remember we said let u be equal to this. Yes, that's our u. So it means it will be tan 3x squared all squared, then we have plus 1. So it means the y all over the x will be equal to 6x sec squared 3x squared all over here we have tan squared 3x squared. Yes, then here we have plus 1. Now, but let's look at this now. Let's look at this. Now, from trigonometric identity, we say sine square x plus cos square x is equal to 1. So it means that when we divide through, we'll divide here by cos square x. It means here we have sine square x all over cos square x plus cos square x all over cos square x is equal to 1 all over cos square x. Now this over this. Now remember we said sine x all over cos x is equal to tan x. Yes, sine all over cos is tan. So therefore means that sine square x all over cos square x is tan squared x plus cos square x all over cos square x is 1. And this is the same thing as 1 all over cos square x. And we know that 1 all over sine x, 1 all over sine x is equal to cosec x. 1 all over cos x is equal to sec x. 1 over tan x is equal to cot x. Now looking at this now, 1 all over cos x is sec x. So it means 1 all over cos square x is sec squared x. Now looking at this relationship, that tan square x plus cos square x, tan square x plus 1 is equal to sec square x. So it therefore means that here, we can have this to be equal to, that's the whole of this value, the y all over the x. The y all over the x now will be equal to, we said is 6x sec squared 3x squared all over, we have tan squared 3x squared, then here we have plus 1. So it means the y all over the x. Now let's look at this relationship. Yes, tan square x plus 1 is equal to sec square x. So it therefore means that this will be 6x, we have sec square 3x square all over. Now tan square 3x square plus 1. It means that will give us sec square 3x square. Yes, let's look at it again. Tan square x plus 1 is sec square x. So it therefore means that tan square 3x square plus 1, it will give us sec square 3x square. So it means the whole of this will go with the whole of this. So it means the y all over the x will be equal to 6x. So that's the value of the y all over the x. If y is equal to the tan inverse of 3x squared. So now I'm going to take question number F now. Let's take note now. Here, we have not actually done this. So please take note. Now I want to take question F now. Yes. And question F, we have y is equal to the tan h inverse. So that's an inverse hyperbolic function. Yes, that's inverse hyperbolic function. So solution. Now in this case, because this is actually taking the position of x. Yes, because the function we said is tan h inverse of x. Now this is the standard function. So if you look very closely, you'll discover that the position of x has been taken over by lane x. So it means this is the function of function. So here we tell them, let u be equal to lane x. And we all know that this lane x is a natural logarithm. It's saying log x base e. Yes, it's a Neperian or natural logarithm. So now it means our y will be equal to tan h inverse of u. Because now we have assigned lane x to u. We say let u be equal to lane x. Now please take note of this. Now, if you have a function like this, tan inverse of x, and you have lane x. Yes, this is not the function of function. Yes, because now there's x here. So this is a product of two functions, u and v. Yes, it's a product of two functions, u and v. But because lane x actually took the position of x here, that's the reason why we call this a function of function. So it means that when you have two functions of x, you treat them using the product rule. But in this case, lane x has taken the position of this x. That is why we call it a function of function. So here, let's look at the y all over the u. The y all over the u. Now let's look at tan h inverse of u, what we actually got there. Now we said if y is equal to tan h inverse of x, the y all over the x is 1 all over 1 minus x squared. Yes, so it means the y du will be 1 all over 1 minus u squared. Yes, 1 minus, this is minus 1 minus u squared. That is the y all over the u. Why? Because if y is equal to tan h inverse of x, the y all over the x is 1 all over 1 minus x squared. Now let's look at the u all over the x, the u all over the x, the u all over the x. Now we all know that when you differentiate ln x, yes, when you differentiate ln x, it gives 1 all over x. Yes, the derivative of ln x is 1 all over x. So it therefore means that the y all over the x, will be equal to the y all over the u times the u all over the x. Now we know this is called the chain. It's called the chain rule. Yes, it's called the chain rule. So the y dx is equal to the y all over the u times the u all over the x. So it means in that case, we have the value of the y all over the x. We have the value of the y all over the x now to be equal to the y all over the u actually gave us 1 all over 1 minus u squared. So here we have 1 all over 1 minus u squared. Then we have times the u all over the x. And the u all over the x, we said, is 1 all over x. So you multiply it by 1 all over x. So it means in this case, the y all over the x will be equal to 1 times 1 is 1. All over 1 minus u squared times x. That will be x in bracket 1 minus u squared. Now recall that, yes, recall that the value of our u is equal to ln x. Our u is equal to ln x. So it therefore means that the y all over the x will be equal to 1 all over x in bracket 1 minus the value of u. And u is ln x. So we have ln x all squared. So the y all over the x now, yes, the y all over the x will be 1 all over x in bracket 1 minus ln x all squared. So this is the value of the y all over the x if y is equal to tan h inverse of ln x. Now we have solved question number A, question B, question C, and question F. So I'm going to leave this question D and E for you as an assignment. So if you have any problem, you can contact me and I'll demystify it for you. Thank you so much, and God bless you.